So when you read this question, a child toy has like 36 slots, number from 1 to 36. Okay. And a child puts a ball into the toy, the ball falls in one of the 36 slots, and the child's score is the number of that number of the slot. Ball is equally likely to fall in any of the slots. So Sadiq is investigating 4 possible events, A, B, C, and D. So the score is odd, even, 3. Okay, so I think the main thing is to understand what are odd numbers and what are even numbers. So because usually these kind of questions, they ask for mutually exclusive or independent. I think a lot of times you'll get very confused when like what is mutually independent events here. So we try to understand first. Score is odd. You need to know how many odd numbers are there. So like from 1, 3, 5, 7, 9, all the way to 35. Okay, so you have 36 numbers here. So understand this one. The number of elements in A, half of it 1 to 36. So you have 36, right? 1 to 36. You count 1 to 36. So half of it will definitely be odd. The other half will be even because it's an even number of numbers you have here. Okay. So this guy is okay. So this is B, which is like 2, 4, 6, 8, all the way to like 36 or so. So you know that the branch that you have here, the number of elements you have here is actually also 18. Okay, so that's not surprising. Then the next thing is the score is a multiple of 3, right? So if you think about it, multiple of 3, this case here, you'll be a bit worrisome. Like you do not know. Multiple of 3 means what? 3, 6, 9, 12, all the way to 36. So how many of it you have? From 3 to 36. Yeah, so I would reckon it's 36, 12 of them, 36 divided by 3, right? So this guy here, NC would just be 36 divided by 3, which is like 12 of them, because 3 times 1 is 3, 3 times 2 is 6, then 3 times 12 is 12, 3 times 12 is 36. So then D would be same thing. You will have multiple of 6, so it's 6, 12. 6, 12, 18, then 24, okay, then 36. So this one, not an issue. This one also, you get and choose number of multiple of 6 would be 36 divided by 6, which is 12. Okay, sorry, 6 of them. Okay, so actually just one more left. This will be, okay, 6 of them. So it's good to list them down to know what is the number you have, the number of elements you have. Okay, now, so the next case is mutually exclusive. Okay, so state which pairs of the events are mutually exclusive. This is 1 mark. Okay, which pairs? You must understand this. For this is also even numbers, right? You see that? So the multiple of 6 are even. Okay, then the multiple of the 3s, right? It has even and odds together. Okay. Then this one obviously not to say this even, because this is even, this is odd. Okay, so you can see very clearly. Now this question here is to test. Now so I'll just quickly write this down. So I'll just quickly go through some of the concepts. So odd times odd is odd, right? Odd times odd is odd. 3, yeah. So how do you show that odd times odd is odd? Is very simple. Let's say odd number, usually odd number is 2k plus 1, then multiply by 2n plus 1. Okay, so what you can do is essentially understand this is n and k, they are integers, integer value. So this would then be 2k, I'll just quickly do this, 4kn plus 2k 2n plus 1. So what you realize that anything multiplied by even number is this one. Okay, maybe you can factorize these 2 up. The definition of even is basically here. This is even. This is an even number. Okay. Then you add a 1. Obviously, this will just be odd. Okay. So it's just odd. So the entire thing will just be odd. So odd times odd is odd. So this case here, we have this is odd number times odd will be odd now. But this 6 here is 1, 2, 3. So it will be what do you call it? A alternating lah. So if you take, okay, then you think about it like odd times even, obviously it's even lah. You can also show it. So from this guy here, you get 2k plus 1. Even number is 2n, where k and n are integer. This one is easy because the entire thing you just need this 2 times this is integer ma. So this is integer. This is which is even. Okay. So this kind of question, I think one of the specimen paper they did ask, like, so like odd plus odd. You can also show odd plus odd is even. Odd plus even is odd plus even is odd. You can do that the same thing. So so I'll give you an example, like odd plus even is odd, right? So you can show by left hand side, odd is 2k plus 1. Even is 2n, where k and n are integers. It's 2k plus n plus 1. So this is even, which is odd. Okay, so you can show. So these are some of the simple notes you need to take. So the concept here is even, odd, even, odd, odd, even. So just a side note. You want to take a photo of this, just read through this for tomorrow's paper. So we haven't started the first question. So you can see that basically A and B are mutually exclusive, because if you're even, you're not odd. And also B and D are mutually exclusive. Okay, mutually exclusive events just means they cannot concurrently happen together. So if you list them now, you'll be able to see what's what. So that's all. Done. Now then after that, usually for this kind of question, they will have one mutually exclusive, then one independent event, just like our mock paper. So just study our mock paper. It's the same thing. So what are independent events? Independent events by definition is PA times PB, PC is equals to PA intersect C. Okay? So state another pair of independent. So show that A and C are independent. So I don't think it's hard to see. So for this part 2 here, PA, we already found is NA, which is 18 over 36, which is half of it. PC, which is NC, which is this guy, 12 over 36, which is a third of it. Then PA intersect C will just be the number of A intersect C over the number of the universal set. No, universal set is 36 lah. So A intersect C, you just ask, A intersect C is just C itself lah, right? Right, A intersect C is just C itself. No, oh no, it's half of C, sorry. A intersect C is just 3, 9, and all the odd numbers. So you just half this, half this. So it's 6, 12 over half, because half of it will be odd, half of it will be even. So it'll be 6 of it. So 6, 1 over 6. So PA times PC is, which is 1/3, which is 1 over 6, equals to PA intersect C. Hence A and C are independent. Okay, this is an interesting one, because if they say state another pair, so A and C are independent, they state another pair of independent events. So remember this one. Okay, this one just remember if A and C are independent, it also means that A prime and C are independent. It also means that A prime and C prime are independent. It also means that A and C prime are independent. Their mutually exclusive events are also all independent of each other. Okay, because if you draw the tree diagram, it has to be like the complement of each other. Okay, so the probability here is all the same. So when the independent events, the probability are all the same. Like this is PC, this is PC as well. Okay, so refer to the summary notes But okay, just remember, if A and C are independent, then all their complement will all be independent. But one thing to take note, this one is also A prime, bro. Okay, this is also A prime, because A prime will be odd number If A is even, then A prime is B So essentially, so hence A prime is also independent of C, right? Independent events. So you know that B and C are independent. Okay, there you go. So B and C are independent. That's that. So for part B, now that one of the slot is being stuck, 36 is stuck, right? Slot 36 is stuck, so you only have 1 to 35 lah. So this asks to state which are the independent. So do the same thing. Basically, this case here, you know that there's no more 36 so you need to update this guy to 17 the new one. There's no more 36 here. This would be 11 This is 35. Oh, yeah. So this one is no longer this case. So you from 12 it becomes 11, right? 11. Then 36 no more here. Then this will be 5. Just 5 of them. Okay. Just update them, but obviously the nature of the numbers are still the so for part B, part 1, A and B are still mutually exclusive this is the same Then for part 2, right, I don't think for part 2 you want to see they are independent or not. You just find PA intersect C. P intersect C now will be still the same is it? A intersect C. A intersect C, yeah, it's still the same. So it's still not the same. The number of the A intersect C is still 6, right? 6 over 35 Now it's 6 over 35. Then now PA is obviously 18 over 35. Then PC is equals to 11 over 35. Okay, so PA times PC. Actually, you don't need to. They just ask whether is it mutually exclusive. You can just say no. I don't think you need to write down the working. But unless they say explain. So since PA times PC is no longer PA intersect C. Okay, A and C are no longer independent events. There you go. So this is just even odd I think, yeah.